we're going to solve chapter 1 review of Big Ideas Math. Remember that this chapter starts with section 1.1, which is transformations. It's a parent function and transformations. These are problems and pages 3 to 10. Usually you can follow the video on these ones, but the learning target of this one is to graph and describe transformations of functions. We're going to graph the function and its parent function. Then we're going to describe the transformation. So the first problem that we have here is hx equals to 4. And this problem is the same as having, we have hx equals to 4, which is the same as having y equals to 4. Okay, so this is your y-axis. And what we're going to do is just draw a horizontal line at y equals to 4. This is y equals to 4. Okay, that's my horizontal line. This is y equals to 4. Now, what is the parent function of a constant? Like we call this is the constant line. It's 1. Y equals to 1. This is the parent function. Y equals to 1. So what I'm going to do is to graph a straight line on y equals to 1. And then I'm going to ask what happened to y equals to 4 from y equals to 1. What happened? Did it go up? Did it go down? Did it move to the left, right? That doesn't happen because it's an extension in the horizontal line. So in this case, we can say that the graph of age, remember, this is the formal answer. We're going to write here, in this case, the graph of age. So we can write for problem number 1, we're going to have the graph of age. In this case, is a translation, 3 units up of the parent function. Of the 3 units up of the parent function. So this graph, I will count how many units went up. 1, 2, 3 units up of the parent function. So that's problem number 1. Problem number 2, let's see problem number 2. Problem number 2 says fx equals x plus 3. So I have fx equals x plus 3. This is problem number 2. What is the parent function? Is the linear function fx equals to x, or you can call this one y equals to x, right? Because this is fx, so you can call this one whatever function. You can call it gx. Doesn't have to match. So remember that the parent function x is positive, so I'm going to make a small table of value. X, y, I'm going to start with 0. So when x is equals to 0, y is equals to 0. Here I'm going to write this one, y equals to x. When x is equals to 0, y is equals to 0. When x is equals to 1, y is equals to 1. When x is equals to -1, y is equals to -1. So it's just going to follow this pattern. When x is equals to 1, 1 and y, 0, 0, 1, 1, and so on. And it follows. So what we can do is just graph a straight line that goes this way. I don't have a ruler right now, so I'm just going to do that one. That's the parent function. This is y equals to x. Now what happens to the transformation, to fx? So I have x plus 3. So that means that this 0 moves 3 units up because I have plus 3. So I go 1, 2, 3. And then I'm going to do exactly the same 1, 1, but I'm going to start. It went right 1, same, 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 and I'm going to graph by the bottom. If you want to do, you can just do a table of value. Okay, I'm going to do it here. For example, x, y. I'm going to start with 0. When x is equals to 0, what is y equals to? 3. See, it just went up 3 units. When x is equals to 1, what is y equals to? Is 4. See, when x is equals to 1, is equals to 4. When x is equals to 2, 5, 3, 6, and so on. So this graph is just a straight line. It should go through those points, but in this case, when 3 units up. So what will be the solution? We need to describe for number 2. Number 2, I have that the graph of f is a translation 3 units up of the parent linear function. Okay, it's a linear function, so we're 3 units up, and that's problem number 2. Let's look at problem number 3. Problem number 3, I have gx. Okay, I'm going to write it here. I have gx equals to absolute value of x minus 1. So I have it here. Remember that the parent function for an absolute value is a V-shaped function. It's a V shape. And it goes by 1 also. So if I have 1 unit to the right, and then I have 1 unit up, because let's do the table of value. X, Y, I'm going to do 0. I'm going to have y equals absolute value of x. If x is equals to 0, y is equals to 0. If x is equals to 1, y is equals to 1. If x is equals to 2, y is equals to 2. Okay, 2. Now, if x is equals to -1, the absolute value of -1 is 1. If x is equals to -2, the absolute value of -2 is 2. So it's all you can move. This is x. You can move to the negative numbers in x, but it's always going to be positive because of the absolute value function. So my absolute value graph, I'm going to write it here. So I go write 1 if I have 0, 0. Okay, 1, 1. If x is 2, then I have that y is, in this case, 2. If x is 3, then I have 3. And it goes the same to the left. Okay, that's the parent function. Go, and it's a V-shaped graph. So it goes this way, V-shape. Now what happened with the problem that we have is absolute value of x minus 1. So I have, let me do the table of value here. So I have x, y, and I'm going to start with the same, 0. If x is equals to 0, here, if x is equals to 0, y is equals to -1. What that means, it went down 1 unit of your parent function. If x is equals to 1, x is equals to 1, absolute value of 1 is 1, minus 1 is 0. Then I have, if x is equals to 2, absolute value of 2 is 2, minus 1 is 1. If I go to the negatives, if I go -1, if absolute value of x, if x is equals to -1, absolute value of -1 is 1, minus 1 is 0. And if I do 2, -2, absolute value of -2 is 2, minus 1 is 1. So I have the following values. So what I got here, so I have, when x is equals to 0, y is equals -1. So we go here. We went down to 1. When x is equals to 1, y is equals to 0. Okay? When x is equals to 2, x is equals to 2, y is equals to 1. And then I go to the negatives. When x is equals to -1, y is equals to 0. And when x is equals to -2, y is equals to 1. Can we see it's the same absolute value, but it just went down 1 unit down. So it went down 1 unit down. So I have that this one is my gx equals to absolute value of x minus 1. So what will be the transformation for number 3? For number 3, I have that the graph of g went down in this case, and the graph of g is a translation 1 unit down of the parent absolute value function. That's the solution for problem number 3. Let's move to problem number 4. Problem number 4, in this case, I have hx equals to 1/2 x squared. So I have number 4, hx equals to 1/2 x squared. What is the parent function? Is the quadratic function. I'm going to have y equals x squared. It's a parabola. So I'm going to have the parabola is this curve. Remember, is symmetric with respect to y. So we're going to have the same distance here, same distance here. So now we're going to do a small table of value if you want. So I have x, I have y, 0, 1, and -1. I just need those values. It's pretty much the same as the absolute value function because it transforms my negatives into positives. For example, if x is equals to 0, y is equals to 0. If x is equals to 1, y is equals to 1. If x is equals to -1, in this case, y is equals to +1 because -1 to the second power is +1. We can do one more. This is the difference between the absolute value and the parabola, is the growth. So I have 2 when x is equals to 2, y is equals to 2 to the second power, which is 4. And same if I do -2, this one is going to be 4. So we're always going to have the same values repeating in the negatives and the positive because the parabola is symmetric with the y-axis. So let's graph it. So I have, in this case, 0, 0. I have 1, 1. I have 2 and 4. Okay. You can do 3 if you want, but it will be 3. 3 times 3 is equals to 9. I don't have 9, but usually it will go around here. And these values will repeat to the left side. How many units? 2. So 1, 2. And I can just do this one, and I will go 1, 2, 3, and same distance. And then you just graph a curve here. There you go. So I have that this one is y equals x squared. This is the parent function. Now I'm going to graph the transformation. Who's the transformation? 1/2 x squared. What happens? Okay, x, y. So we have, I'm going to put 0 here. 0. So when x is equals to 0, y, hx is equals to 0 because 0 to the second power is 0 times 1/2 is 0. Then I have, when x is equals to 1, 1 to the second power is 1 times 1/2 is 1/2. When x is equals to -1, so I have -1 to the second power is 1 times 1/2 is 1/2. Then when x is equals to 2, 2 to the second power is 4. 4 times 1/2 is 4 over 2, which is 2. So this one is -2. This one is 2. Okay. And with -2, it's going to repeat this value. So when x is equals to -2, y is equals to 2. I'm not going to do 3. I'm going to do 4. When x is equals to 4, okay, y is equals to 4 to the second power is 16. 16 divided by 2 is 8. And if I do -4 here is also 8. Okay, so now if I graph in this case, the transformation, I have 0, 0, same vertex. Then I go 1, when x is equals to 1, y is equals to 1/2. So half unit. And then I go, when x is equals to 2, y is equals to 2. In this case, -2. I have 2. And then when x is equals to 4, I go all the way up to 8. Right, to negative 4, so I go to 8. So my graph goes this way, goes this way. So what happened? I'm going to write the solution here. What happens to this graph? The graph of age is we call it vertical shrink by a factor of 1/2 of the parent quadratic function. That's the parent quadratic function. And in this case, a vertical shrink of a factor of 1/2. Remember, if we have 1/2 is a vertical shrink, that means the graph start getting bigger around the parent function. Okay, that's number 4. Let's look at number 5. Where number 5 is, I have -3 is gx -3. Let me write it here. So I have number 5. I have gx equals to -3 x plus 3 to the second power. I got it here. Okay, so now what we're going to do for this problem, now as we can see in this problem, there is a transformation inside the x, because before we had x squared plus 3, now we have x plus 3 to the second power. So it's going to be a movement in the x-axis or the horizontal line. Now remember, we start with the parent function. So the parent function in this case is y equals x squared. We already had that table that has 0, 0, 1, 1, 2, 4, 1, negative 1, 1, and negative 2. We have 4. Now what happened with the transformation? So I'm going to have 0. I'm going to start with 0 always. 0 is the to-go point. So I have, when x is equals to 0, y is equals to 0 plus 3 is 3, to the second power is 9, and then times the negative 3 is negative 27, right? That's when x is equals to 0. Now I'm going to do when x is equals to, let me go to negative 1. When x is equals to negative 1, I have negative 1 plus 3 is 2. To the second power is 4 times negative 3. In this case, is negative 12. Okay, so it's still big numbers. So let me go back to the negative numbers. So I'm going to do negative 2. Negative 2. So I have negative 2 plus 3 is 1. 1 to the second power is 1 times negative 3 is negative 3. Let me go to 3. Negative 3. Negative 3 plus 3 is 0 to the second power is 0 times negative 3 is 0. This is my vertex because in this case is the x-intercept. And then we're going to see in the graph. So let me remove this one. I'm going to do one more. Negative 4. Negative 4. So I have negative 4 plus 3 is negative 1. Okay, it's negative 1. To the second power is 1 times negative 3 is negative 3. Okay, so I'm going to stop here because now I'm repeating the numbers. So if I do negative 5, I'm going to get negative 12. If I do negative 6, I'm going to get negative 27 and so on. So now I'm going to graph those functions. So remember that the parent function that we have is y equals 0. We have 0, we have 1, 1, 2, 4. In this case, that was 2 and 4. Same here, and then we had same here, and this was my parent function. Okay, and now with this function that we have here, right? Now with this one, I have that negative 3, 0, that's my x-intercept. So I have this one here, and I'm going to start with negative 2. So negative 2 is negative 3. Negative 2 in x, negative 3 in y. Then I'm going to have negative 4 and negative 3. And then if I remember that I did negative 1 and I got negative 12, so negative 1, negative 12 is like around here. So if I do negative 5, I'm going to get the same point. So this parabola is this way. It's coming this way. And because the 3 in this case is negative, opens down. So what we're going to do, we're going to describe this one. So we have two transformations on this one. We have the x plus 3, and we have the negative 3 and 3. We have the 3 and the negative number. So we have 3 transformations. So what would be the description of this one? I have the graph of G is a vertical stretch by a factor of 3. By a factor of 3, followed by a reflection in the x-axis. And in this case, a translation 3 units to the left of the parent quadratic function. And that's the solution, right? That's the transformation. Now, the next problem that you have there is the absolute value of the negative absolute value of x minus 3. I'm going to try to do it here really fast. So remember that the parent function is something like this one. That's the parent function. Now we have an absolute value that is negative. So instead of open up, I'm going to use this pencil here. Now it's going to open down. This one is the negative absolute value of x. But now I have negative 3. So that means that this graph is going to go down 1, 2, 3 units. So I'm going to start my graph from, remember, same distance, my graph this way. So this one is the fx equals to negative absolute value of x minus 3. So how do you describe this function for problem number 6? This is problem number 6. I'm going to write on this one, right? The graph of f. I'm just going to write this, the graph of f, okay, is a reflection in the x-axis and a translation three units down of the parent absolute value function. Okay, that's the solution for problem number 6. I'm going to do number 7. Let's see how that problem solved. What I have here, I have that the graphs of f and g are shown. So I have two graphs here. Describe the two different transformations from the graph of f to the graph of g. Now this is f and this is g. They are a linear function, okay? They are a linear function, and in this case, this graph, I'm assuming this graph is moving to the left. See, it did not went up, went down. It just moved to the left because there is the same distance, and you can see the distance here. So in this case,